Hey guys, welcome back to another video tutorial. In this video, I'm gonna explain you what is the significance of 3dB in engineering. So to start off our discussion, let's consider a function or an equation which is given by y equals x. So if we plot a graph, the graph will look like a straight line, okay? Because it is a linear equation. And if we consider another equation with the function given by y equals 10 raised to the x, the graph will look like an exponential function, right? So what happens if we take log on both sides, log to the base 10, or you would say it better natural log. So what happens if you take the natural log of this function? So according to log property, this x will come down, and log of base 10 with the quotient 10, you will get x. So you can plot this in terms of log x, right? So you can say that it is x, and the vertical line represents the log value, right? So in engineering, you will get to know about gain. So basically, gain is the output voltage with respect to input voltage, right? So we usually talk about gain in dBs, right? So if we take log 10, we'll get log 10 of the gain, right? We'll get bell, right? But if we multiply by it the 10, so we'll get decibel. So we can say that the gain in decibel is given by 10 log base 10 in the argument you would put in your gain value, right? But what happens when the gain is twice, right? So according to log property, you can multiply, you can split things up when they are in multiplication. So you can take the log for this value, and you can take the log for this value, right? So the log for this value is 3 dB, right? So we can say that as gain is double, the in dBs we add 3 dB. So this is why 3 dB is very important, which means then when the gain is double, in dBs we add 3 dB to the original gain, right? So if the gain is reduced to half, we can say that you can say like in log property, if something in the denominator, we subtract it. So we say that there is 3 dB reduction. When the gain is half, there is 3 dB reduction, right? So here's the plot. This is most likely of a low pass filter, where the gain, we assume that this has a 3 dB bandwidth, right? So basically it is not an ideal low pass filter because it does not have any sharp cutoff. So in order to say what is the bandwidth, we said that the 3 dB is our bandwidth, which means that when the gain is half, this is not the half in the original half, this is logarithmic half. When the gain is half in logarithms, which is around 0.7 or 70% reduction, we say that this is the 3 dB value, or we can also say that this is our cutoff value.